So here we have problem 31, page 143. As shown in the figure, we have fx applied on the object m2. m2 equals to 8 kilogram. Fx is horizontally along the x-axis. We can say the horizontal surface is frictionless, so we don't have interaction between the object m2 and the plane. Mu equals to O. The question is, okay, we have here m1. So m1 equals to 2. Here, for what values of fx? We have many values of fx. For what values of fx does the mass m1 accelerate upward? Okay, it means I need to calculate the value of fx in order to have a acceleration, in order to have a positive. Anyway, you know that here we have an inflexible cord attached between m1 and m2. It means the acceleration of m1 equals the acceleration of m2. We can say here we need to calculate the values of fx in order to have a positive. So we have to find a relation between fx and a, and we can discuss about the question. Here, before, I want to write the given. We can say, first of all, that the pulley is massless and frictionless. It means the axis of the pulley doesn't do any friction, and the pulley without mass. In this case, the tension on the left and the right of the pulley, we have the same tension. We can say T1 here equals to T2. We can say equals to T. We have T to the left and to the right of the pulley. So we can say T1 equals T2 equals to T. First, here we have T1 and T2. Here, T1 and T2. We can say T1 equal T2. Let's draw the masses applied on each object or the forces applied on M1 and M2. Here we have M1, M1G, and M2G. The reaction from the table on the object, we have N, M2G. And here we have M1G. Okay, we have the tension, we have everything. The motion, the system moves, the mass M2 moves to the right, so we have a clockwise motion. The mass M1 moves up in the positive direction, and the mass M2 moves to the right in the positive direction. Okay. Now let's apply Newton's second law. We can say before also the first point, the second point, we can say the cord is inflexible, so A1 equals A2 equals to A. Okay, and we have the same V. V1 equals to V2 equals to V. By applying Newton's law, the summation, you know, we have to take M1 alone and M2 alone. We cannot combine these two objects by one system. We take now M1, what we have on M1, summation of F on the object 1 of the summation of F equals to T plus M1G equals M1A. Okay, here we have T in the positive direction up, so T minus M1G in the negative direction equal M1A. You know that here we have acceleration. So A must be up with the same direction with the velocity. Okay, if we have a deceleration, if the velocity decreases, A must be opposite. Here we have acceleration. E must be up with the same direction with a positive. Okay, for this reason, I put plus A. You can put here J, and J. Okay, and you can cancel. You don't have I. You can put and you can cancel. It's the same, whatever. Okay, so T minus M1G equal M1A. It's the first relation between T and A. Me, I want a relation between Fx and A. Let's take the first object M2. For M2, the summation of F, we have T plus N plus M2G plus Fx equals to M2A. Okay. Now T in the negative direction minus Ti, Fx in the positive. Okay, we have N before. Okay, I will put all the x-axis direction. We have minus T and plus Fx. So plus Fxi, you can write a common I minus T plus Fxi. N is positive, so we have N minus M2G, M2G in the negative direction, J equal M2A. Here, A with a positive direction. A equal AX. We don't have X motion. We don't have a motion with respect to Y. So here we can say, you can say AI. We don't have a motion in the J direction. We don't have motion like this. The motion is only in the X direction. For this, we have A as value equal AX. We don't have AY. Okay. Now I take I component here minus t plus fx equal m2a, okay? And we can say n minus m2g, n minus m2g equals to 0. Okay, I don't need to talk about n because we don't have friction. Okay, so we can take only this equation. Here we have equation 1 and equation 2. We can I need just a relation between fx and a. I don't need t. For this, I can substitute the value of t. We can eliminate the value of t in order to have just a relation between fx and a. So we can take equation 1, for example. We can calculate t. T equals to m1a plus m1g. And we can use equation 2. We substitute the t value. We have t minus t minus m1a plus m1g is the value of t. I put t by its value here. Okay, I am using this equation plus fx equal to m2a. Okay, we can calculate a. Let's continue here. We can write minus m1a minus m1 g plus fx equal to m2a. So we put a here. We get a equals to fx minus m1 g divided by m1 plus m2. As you see here, we have a relation between a and f. Look here. What is the value of x in order to have a positive value of a? It's easy here. Fx, in order to have a positive value of x of a, fx must be greater than minus m1, greater than m1g. Because if fx equal m1g, you will get a equal to o, to 0. So to have a positive value of a, fx must be greater than m1g. Okay, any value of fx greater than mg we can get acceleration. So fx must be greater than m1g in order to have acceleration. I mean a positive. Okay, this is the answer. For this reason, we have many values of fx. All the values greater than m1g give us a positive value of a. Okay, here m1g, we can say fx must be greater than m1 equals to 2, g equal to 10, so must be greater than 20 Newton. This is part A. Now I want to solve part B. Here I ask you for what values of fx I need to calculate the values of fx in order to have a zero tension in the cord. So T, to have T equal to 0. Okay? I come back. Here, we can, okay, we can come back here. We have to solve so I want to calculate the values of fx, how much, in order to have t equals to O. So we need to calculate a relationship between fx and t. I mean, we have to eliminate between the equation 1 and 2, we have to eliminate the value of a. We can substitute the value of one equation in the other equation. So we need to eliminate a. Okay, we have equation 1, t minus m1 g equals to m1 a. We can say a equals to t minus m1 g divided by m1. We substitute this value in equation 2, which is equal to minus t plus fx equal to m2a. Okay, we put the value of a here. We get minus t plus fx equal to m2 times a, m1 t minus m1 g. Here we have to find the value of t. So minus t plus fx, we can say times m, okay, minus t m plus m1 plus fx m1 equals to t m2 minus m1 tm2 minus m1 m2g. Just we did this, okay, this one times this one. Okay, I want to calculate t. I take a common value of t. We get t equals to fx m1 plus m1 m2 g divided by fx plus divided by m1 plus m2. This is a simple relation between t and fx. I need to calculate the value of fx in order to have 0t. Okay, we can simplify this equation. We can write m1 fx plus m2 g divided by m1 plus m2. Okay, when we have t equal to 0, when fx equals to minus m2g, if we put fx equals to minus m2g, we get t equal to 0. Okay, it's clear here. So simply you have to find a relation between t and fx. So t equals to 0 when fx less than or equals to minus or equals to, you can say fx to minus m2g. Let's say, so fx must be less than minus m2 equals to 8, g equal to 10, so, or we can say g equal 9.8, okay? We get 78.4 Newton. This is the answer. Okay, this is the second problem. We can solve the third one. Plot the acceleration. Okay, we don't solve this one. It's not important, okay? That's all.